Hello, I'm Mrs. Wilkins and welcome to Malmesbury Science. We're going to investigate one of the 3 gas laws that you will meet in thermal physics at A-level. Charles's law states that at a constant pressure, the volume of a fixed mass of gas is proportional to the temperature. It's actually a really simple and straightforward setup and investigation to do, but it's really important because it allows you to investigate this relationship yourselves and also to determine a value for absolute zero. This is the equipment that you need. You are going to need a capillary tube, a thermometer and a ruler. And we have a nice little set that has them clipped together, but you can attach the 3 together yourselves. The capillary tube is what holds the gas. The gas that we have is just dry air, and it is trapped inside the tube with a thin layer of oil. But you may have a capillary tube that has a drop of sulfuric acid to trap the gas. The tube is closed at the bottom but open at the top, and that allows the pressure to remain constant at atmospheric pressure. This kit allows us to look at the change in volume of gas. But actually, we're not actually measuring the volume of gas, we're measuring the height. But that's fine because the gas is in a cylindrical tube, and therefore we can say that the height of the gas is proportional to its volume. So we're going to look at the volume change by measuring the height change. And you can do it 2 ways. You can either do it as you heat the gas, and the gas will expand, or as you allow the gas to cool and it will start to contract. We're going to do it by adding freshly boiled water, so as close to 100 degrees as possible, and we're going to measure the temperature and the height of the gas as the water starts to cool. This is a slightly slower process, and then hopefully will ensure that the gas is at thermal equilibrium with the water. We can say that the temperature of the gas is the same as the temperature of the water, and we will be measuring the temperature of the water. Okay, so we have our freshly boiled water. We're going to add it to the beaker. Obviously, be careful here that you don't spill the boiling water onto your skin. The volume of the gas is going to rise as it expands, so you want to make sure that the water covers the whole of the gas. So we're going to put it right to the top. It's important to take the measurements at eye level, as this will reduce the parallax error in your measurements. And also, if you're setting up your equipment, you really want to make sure that the capillary tube is really close to the ruler and close to the scale on the ruler. So our first reading has a temperature of 95 degrees Celsius and a height of 11.8 centimeters. And we're going to watch as the temperature drops, and I'll take the next measurement at 90 degrees and take the height of the gas. We now have a full set of data, and you want to make sure that you have at least 8 measurements to be able to plot your graph. So we have our temperature and we have the height of the gas, and we're going to plot a graph of the height of the gas in centimeters versus the temperature in degrees Celsius. We can plot the graph, and there's 2 ways that we can use this to find a value for absolute zero, which is where the volume of the gas would theoretically get to 0. You can either draw the graph by hand and extrapolate the graph to get your value for absolute zero. However, that's not a particularly accurate way of doing it, and so you can also do it algebraically. Here's the graph that we've drawn. We've calculated the gradient, and then we're algebraically able to find a value for absolute zero. Hopefully you will get a value close to the true value of minus 273.15 degrees Celsius. Of course, it won't be exactly this, and you might like to think of the reasons why and the errors involved in the investigation. Our value we have calculated is close to that value. There is less than 10% error between our value and the accepted value. We hope that you have found this helpful. Please check out our playlist, which shows all the videos for every A-level physics required practical.